We have a question. A projectile is fired from a horizontal ground with a speed v and projection angle is theta when acceleration due to gravity is g. The range of projectile is given as d. If the highest point on a trajectory, the projectile enters a different region where the effective acceleration due to gravity is g prime, which is equal to g divided by 0.81, that the new range is d prime is equal to n multiplied by d. So we have to find out value of n. So it means we have a projectile, and let us suppose this is fired at an angle theta with the velocity v. If this is the highest point, then to the left of this highest point we have gravitational acceleration due to gravity g, and to the right it is g prime, and it is also given that after this point the acceleration due to gravity is going to change, so we are going to have a different path that will be taken by this projectile. So if this is the highest point, it means this point will be the midpoint for the projectile if originally that is traveling with acceleration due to gravity g for the entire duration. And we also know in that case the range is given by d. It means that half of this d by 2 will be the point where will the maximum height. Let us suppose the next part is represented by x. And secondly, it means now the new range, that is equal to d prime, will be given as d by 2 plus x. So in this case we are going to use two main formulas. One is given as the range formula and another one is of the height formula. So range in this case is represented by small d, so which will be equal to u square sine 2 theta divided by g, and if this is height h, then the height h will be given as u square sine square theta divided by 2g. And the question is also given that the g prime is equal to g divided by 0.18. So we are going to use the distance equation, that s is equal to ut plus half gt square. So we are going to take it in y direction. So in y direction, at the top point this value is 0, and s of y is given as minus h, which is equal to minus 1 by 2 g, and let us suppose g prime, and this is t prime at the time. So we get t prime is equal to 2h divided by g prime square root. We already know what will be the maximum height h, which is given by the equation u square sine square theta divided by 2g. So we put the value of h in this, it will be equal to 2 multiplied by u square sine square theta divided by 2g square root. And g prime is equal to g, so we substitute this value, we get this as two multiplied by u square sine square theta, and g prime is g multiplied by 0.18 and its square root. So 2 cancels out by 2 and we get this as u sine theta divided by g, and square root will be 0.9. So this will be our t prime equal to t prime. Now the horizontal distance x we are going to find out. So x will be equal to u cos of theta multiplied by t prime, where u cos of theta is the horizontal velocity at the highest point, u cos theta, and we also know that this will be constant entire journey. So now we substitute value of t prime, we get u cos of theta multiplied by u sin theta divided by g into 0.9. This is equal to u square. If we divide and multiply by 2, we get sin theta cos theta divided by g into 0.9. So this is equal to, this can be written as 0.9 multiplied by u square sin 2 theta divided by g, and sin u square sin 2 theta by g is nothing but d. So we get this as 0.9 divided by 2 and d. So value of x is equal to 0.9 divided by 2 multiplied by d, and relation given to us is d prime is equal to n multiplied by d, and from here you can see that d prime is equal to d divided by 2 plus x. So if you put value, we get d prime is equal to d by 2 plus x, d by 2 plus x. So this is equal to d by 2 plus 0.9 divided by 2 multiplied by d. So d prime is equal to, we take d as common, so this will be equal to 1 by 2 plus 0.9 divided by 2, which can be further written as d. 2 will be the LCM. This will equal to 1.9. So we get d prime is equal to 0.95 multiplied by d. So we are going to compare these two equations. So you can clearly see the value of n will equal to 0.95. This is the final answer. Thank you.